Today's math lesson is lesson 13 in our unit on adding and subtracting fractions. Today the objective of the lesson is to use fraction benchmark numbers to assess the reasonableness of addition and subtraction problems. So for the video today, I'm going to do two different types of problems. One is represented in 1B and the other kind is represented in 3A. The first part of the kids' homework, they have to do problems like 1B, where they don't actually have to solve the problem exactly. They just have to tell if their answer is greater than 1 or less than 1. And they're going to do this using benchmark fractions. Let me show you. 5/8 is close to the benchmark fraction 1/2. It's more than that. 3/5 is also close to the benchmark fraction 1/2. 3/6 would be 1/2, but this is 3/5. Since this fraction is more than a half, and this fraction is more than a half, we know that the answer will be greater than 1, because a half and a half is a whole, and if they're both more than a half, the answer is greater than 1. So that's how they'll use benchmark fractions to solve something like that. Then you have problem 3A, where they're comparing. They're not actually calculating exactly both sides of the blank line. They're just comparing and using benchmark fractions. For example, if I were to add these two whole numbers together, I would get 7. If I were to add these two fractions together, well, 4/5 is a little less than 1. 2/3 is a little less than 1. So both of them together is about 2 wholes, but less than that. Okay? So I'm looking at my answer being almost 9, a little bit less. Well, isn't this almost 9, a little bit less? So I would say in this case that my answers are equal. And that's how you use benchmark fractions to solve these kinds of problems. A student named William in the class just brought to my attention another way of looking at this problem, which I like very much. So you could look at this problem as 5 plus 2 is 7. And then you have this 4/5 that you also add on. So that's 7 and 4/5. And when you add this 2/3 to it, when you add the 2/3 to the already existing 7 and 4/5, you would not reach the benchmark of 8 and 3/4. You would not reach that. So you could say that 8 and 3/4 is more than the 5 and 4/5 plus the 2 and 2/3. To be honest with you, what we're working on here, I think I would accept either answer, to be honest with you. Even though this one is more correct, which William pointed out, and I like his reasoning very much. But as long as they're using this type of reasoning, using benchmark fractions, I will accept a couple different answers depending on the problem.